That thing cost $250 billion. And it's just poof. Everyone's always really surprised to hear that I didn't watch a lot of sci-fi growing up. They're always like, how did you become an astrophysicist if you weren't inspired by sci-fi? But let's be honest, anything space can make is way cooler than anything that sci-fi has ever made. I feel like the comments section is going to take that comment pretty hard, but I stand by it. So I've seen a lot of recent sci-fi, but I missed out on a lot of the classics, including Star Trek, which I reacted to last time, and Contact, which came out in 1997, and I'll be watching and reacting to today. The premise is that Jodie Foster works for SETI, the Search for Extraterrestrial Intelligence, and detects a radio signal from space that they think is from other intelligent life. It's based on Carl Sagan's book of the same name, so I have really high hopes for this one. A lot of my colleagues have told me they really enjoyed it and it inspired them as kids, so I'm quite excited. So here it is, my reaction to the film Contact, and of course, for all of those of you who need warning, there'll be spoilers ahead. It is so good to see Arecibo. Like, I mean, it's a spectacular sight anyway, right? It's this huge dish that's like 300 meters across in Puerto Rico in the USA. It's a radio telescope, you know, it helps us detect emission from hydrogen and shows us where the gas is in galaxies, and it helps us detect things like pulsars. But it's good to see it because it recently collapsed back at the end of 2020. And that was a really sad sight to see. It was a massive blow to the scientific community and the community in Puerto Rico too. No. So I was all ready to be like, this is fairly realistic in terms of what a night observing would look like. You know, you've got the darkened room, you've got the computer telling you what coordinates that you're looking at, you've got headphones on, listening to music, but she's just unplugged her headphones from the machine. And I think that she's been listening to signals from the telescopes, which, you know, radio receivers, they pick up radio waves, yes, but radio waves are light waves, not sound waves. And I know that can be a bit confusing because we talk about like listening to the radio and like talking over radios, but the way those radios work is that your voice and the sound wave is actually encoded on the light wave, on the radio wave, which is then sent out and then it's received on the other end and then decoded and then put out as a sound again. What they're detecting here is actually light from space at radio wavelengths, so not sound. They're detecting light. You could technically turn like the detection, like every time like a photon hit the detector, it would make a sound or something, but like you wouldn't do that in real time. They're detecting light here, not sound.
Must have been a star quick.
I think it's great that you listen. Most people don't do that anymore.
No one ever did it, mate.
When did you know you wanted to be an astronomer?
Well, when I was about 8 years old, I was watching the sunset, and I asked my dad, "What's that bright star over there?" And he said that it wasn't really a star at all. It was actually...
That's not a star, that's a planet.
A whole planet called Venus.
That's the planet Venus.
I'm actually getting like a little bit emotional watching this because that is very similar to my story of like how I ended up knowing that I wanted to become an astronomer. You know, I was maybe 10 years old and I remember stargazing with my parents and some family, and I remember asking, oh, what's that red star there? Like, why is it red? And I was pointing at Betelgeuse in Orion, and none of my family knew. And I remember being like, how do you not know this? How do my parents not know the answer to something, right? And I had to go find it out myself. And I was amazed when I found out that it was because it was Betelgeuse and it was hundreds of times bigger and much cooler than the sun. And I remember my mind just being blown. And from then on, I just wanted to find out as much as I possibly could about space. And I guess that's what led me to becoming like an astronomer and astrophysicist today, right? Like, I kind of actually wish that I had seen this film as a kid, you know, around maybe like 13 years old when you're in that sort of awkward teenage phase. I think it really would have given me like such a boost and such an inspiration that was like Dr. Alloway. That would have been incredible. And I can see now why so many of my colleagues were inspired by this film as well. And I'm sure people around the world will be, like, in generations to come.
This is a unique time in our history, in the history of any civilization. It's the moment of the acquisition of technology. That's the moment where contact becomes possible. The Very Large Array in New Mexico is the key to our chances for success. With its 27 linked radio telescopes, we can search more accurately than at any other conventional facility.
That's not technically true, I don't think, because I'm pretty sure that even though like the VLA has these like 27 different antennae that make it up and that you can move around, it still has a smaller collecting area than Arecibo, this giant, 300 meter wide dish. Anything, Becky, will help me out here and correct me if I'm wrong or let you know how much bigger it is. If the VLA has a smaller collecting area, that means that it can't detect as faint signals as the Arecibo can, so they probably would have been better just sticking with Arecibo. All right, so I'll admit the VLA does look better on film probably than Arecibo, which is probably why they went for it. Also, for those of you who are confused as to why she is observing or listening, if she has to, during the day when, astronomy is something you do at night, radio astronomy you can do during the day because the sun doesn't give off a lot of radio light, so it doesn't really interfere with any of the signals that you're receiving from further afield in space. As long as you don't point your big telescope dish, which essentially acts like a magnifying glass, directly at the sun, then you're good to go.
These are government-owned telescopes. They can lease them to whomever they want, and they don't want the high priestess of the desert using them anymore. Staring at static on TV for hours at a time, listening to washing machines? Did you really think these stories wouldn't get around?
I was looking for patterns in the chaos. Come on.
It doesn't matter anymore. We're a joke to them.
So it is really difficult to get telescope time. Like, it's massively oversubscribed, right? And there's a panel of expert astronomers that essentially read through the proposals that everyone's put together, and it's supposed to be done on scientific merit alone, and it's done anonymously to avoid that kind of situation. It's also worth stating that SETI funds some incredible research that's very worthwhile and definitely not belittled by the scientific community. They do everything from planet habitability studies to studying the first stars and planets that formed, but also searching for strange radio signals from space with the Breakthrough Listen project in Berkeley, California.
Talk to me, guys.
Partially polarized set of moving pulses, amplitude modulated.
We're locked. Systems check out, signal across the board. What's the frequency?
4.4623 gigahertz. Hydrogen times pi. Told you.
Hydrogen times pi. What? Wait, even I can't keep up with all the bloody jargon that's flying around here. What did she actually say there? What was the frequency?
Across the board. What's the frequency?
4.4623 gigahertz.
4.4-ish.
Hydrogen times
pi. Yeah. So I think she's talking about the hydrogen 21 centimeter line here. So the hydrogen 21 centimeter line is this prolific emission line. So hydrogen gas all around the universe gives out this very specific wavelength or frequency of light. The wavelength is 21 centimeters. I only know the wavelength. I actually don't know the frequency of the 21 centimeter emission line. Let me just look that up quickly, because then I think what she's talking about is that if they've multiplied that frequency by pi, it would show that it's like not a natural thing. It would show that it's actually like something that's intelligent life. So yeah, the 21 centimeter line is 1,420 megahertz. So if you times that by pi, which is roughly 3-ish, you're going to get something around 4.4. So yeah, they've multiplied the 21 centimeter hydrogen emission line that is like a naturally occurring phenomenon that everyone who, has technology that would allow them to detect the signal would have also detected the 21 centimeter line. And so timesing it by pi shows them that it's probably not natural in origin.
And pull up the star file on Vega.
It doesn't make any sense. The system is too young, so it can't have a planetary system, let alone life, let alone its
This totally would happen. Like, Vega is one of the most studied stars ever because it's one of the brightest stars in the Northern Hemisphere. You can actually see it right now if you're in the Northern Hemisphere. It's up really early morning, just before sunrise, towards the east, like just to the right of Cassiopeia. It makes one of the sort of vertices of the summer triangle as well, which you can pick out even if there's loads of light pollution because they're some of the brightest stars in the night sky, in the Northern Hemisphere at least.
Whatever the signal is, we better do something soon. Vega's gonna set.
Deposition is confirmed. We've got 4.4623 gigahertz.
So this has to be set in the Northern Hemisphere summer. Otherwise, you would never be able to hand over to CSIRO in Australia to see this, because Vega wouldn't have risen above the horizon in the Southern Hemisphere summer when it's pointing the wrong way to see stars that tend to be in the Northern Hemisphere. So, sometime between, let's say, May and September, I guess this is set. Just from stars, you can tell.
The rumors are flying, the implications extraordinary. This morning's detection of an unidentified radio source from deep space can neither be confirmed nor denied.
So, you wouldn't, like, this wouldn't happen, right? You wouldn't detect the signal the previous night and then that morning have the world's media descend on the VLA wondering what on earth has happened, right? You wouldn't announce it to the world that quick. You would go through every other single possible explanation, do so much rigorous science on it to check before you then wrote up your results in a paper, and that paper was peer reviewed by another astronomer, and then it was finally published in an academic paper and announced to the world, right? That would be the stages that you'd go through, because you wouldn't want to announce it and you not be right and someone else just point out that it's something that's already known, and then you look a little bit stupid. That process can take years though, right? And probably in that time it would become the worst kept secret in the astronomy community, right? Like the B modes in the bicep data, or the optical counterpart for the LIGO gravitational waves. But we'd all stay very tight-lipped about it, because the last thing you would want is to announce it too early and not actually be what you've claimed it to be. Because as she said earlier,
If we go public with this and we're wrong, that's it. It's over. We're cooked.
To better explain to you the events of the last 48 hours, I'm turning you over to the leader of the scientific team that made this remarkable discovery, Dr. David Drumlin, Special Science Advisor to the President.
What? He took credit for her discovery? Are you freaking kidding me? He's an absolute especially because he was the one that cut their funding from Arecibo in the first place. Oh, that's made me so angry. I dread to think how many times that this has actually happened, in real life in the scientific, history of the world. That someone more senior has took credit for a discovery that a more junior person made. It massively reminds me of Jocelyn Bell Burnell, who discovered pulsars from strange radio signals, radio data telescopes, right? But it was her PhD supervisor, Anthony Hewish, that won the Nobel Prize for the discovery, and she didn't.
Well, I saw the thing coming out of the sky. It had one long...
I was just thinking about how that would be a nightmare if that happened today, because everyone would bring phones with them, and the radio interference from those phones would be crazy. You wouldn't be able to do any astronomy. That's why so many radio telescopes have big sort of exclusion zones that say no phones. If you go visit Jodrell Bank in Manchester, you have to turn off your phone or put it on airplane mode, because woe betide you if you interfere with any of their observations. I hate how this film seems to be pitting science against religion, such a massively overused trope. Yes, some scientists are atheists, but there are some that are also very religious and have faith as well. The two things aren't mutually exclusive, right? And if there's anyone out there who wants to be a scientist but thinks they can't because they're religious, that's ridiculous. Please continue becoming a scientist, right? And don't think that faith would ever be belittled by the scientific community either. I'm an atheist myself, but I have so much respect for those who have faith and for their religious beliefs. It brings people so much hope and happiness. Why would you want to take that away from people? I just don't need it for myself, that's all.
Now, by doing this, you're willing to give your life. You're willing to die for it. Why?
From as long as I can remember, I've been searching for something, some reason why we're here. What are we doing?
So I think there's this weird misconception that scientists are properly wedded to their work, and work is all they do and that's their entire life. But if someone said to me, you could finally find out what's inside a black hole, but there's a 90% chance you die, I'd be no thanks. I'm good. I like my life outside of work, thanks. That's not all the things that I've got going for myself. I'm fine.
And I promise I will do my best to represent my nation, my planet, and my God on this historic journey. I thank you from the bottom of my heart.
Of course they picked that guy. Drumlin or Gremlin or whatever his name is. Oh my god, I'm so mad. The guy that has just been a hindrance to the entire project this whole time, and who even cut their funding and then took credit for the original discovery. Oh, I'm so angry. Well, I was mad at him, but I didn't want him to die. Oh my... That thing cost $250 billion. And it's just poof.
Mr. Haddon, where are you?
The Russian government was kind enough to give me accommodations on Mir.
You're living on a space station?
So Mir is, the Russian space station, right? And it operated, I think, through the late 80s, early 90s. Editing Becky, you'll correct me. But they did have some European collaborations in that time as well. So, for example, Helen Sharman, who was the first Briton into space, went to the Mir space station, I think in the early 90s.
Is this all radiation? It's a star. I must have gone through a wormhole.
Ugh, they went with wormhole. Okay, fine. It's something that connects like 2 points in space-time. Now, it's completely hypothetical, but it is technically like a valid solution to Einstein's equations. So it's like a valid thing mathematically, at least, like his equations of general relativity, which say that like mass curves space-time, and that's how we experience gravity. Now, a wormhole is not a black hole. And that is something that like Hollywood and films over the years have always got wrong, and it's something that confuses the public a lot too, like no offense. But a wormhole, it would be a very gentle curvature of space-time. It's something that you can travel in and out of as well. So it never gets like so steep that be that point of no return that you'd have to be traveling faster than the speed of light to escape, like what you get with a black hole. You can think of a wormhole as like 2 funnels back to back, providing that little shortcut through space. Whereas a black hole is like a funnel with its bottom bit of it like pinched into that singularity, and you end up with that point of no return. And again, although black holes have been observationally confirmed, a wormhole hasn't. They are completely hypothetical.
And yet every scientific instrument confirms the IPV was out of contact for only a fraction of a second. Isn't that correct, Doctor?
A fraction of a second Earth time, yes.
Earth time.
Senator, I believe that
I'm really confused here, because they're saying that this pod that she traveled through this wormhole in, right, it just fell straight through the machine and nothing happened for them. It was just that their instruments like registered this tiny fraction of a second where they didn't actually detect anything. Whereas Ellie's claiming that she was in the pod for like 18 hours. And they're saying it's because of like time dilation and relativity, right? Which is this idea that the faster you're moving, the slower time goes for you. So you get in a spaceship and you could be traveling at some fraction of the speed of light for a good number of years. It would feel like 4 years to you, sort of fly away and come back. And when you got back, say 40 years had passed on the Earth because time was traveling slower for you. But it's like time was traveling faster for Ellie to experience 18 hours when they only experienced a fraction of a second. So that would be like she was traveling slower than the people of Earth through this wormhole, which is why I'm really confused here. Oh, for Carl. All right. Final thoughts. I hate films that don't have closure at the end, like Arrival. It was like, no one believed her, but Everybody believed her. And then they didn't make public the fact that her body cam recorded 18 hours of static either. I feel like that might have been an important fact to include in a court proceeding. And then why didn't they just send someone else in the machine? They spent $250 billion on this twice because they had to build 2 of them. And they're just going to, leave it sitting there looking all nice and shiny and not send anyone else in to corroborate her story, maybe? That would have been a good idea, wouldn't it? So all that aside, and the fact that she listens to radio telescopes as well, I don't think I'll ever get over that. All of that aside, I really, really did enjoy this film. You know, when you just switch the astrophysicist brain off, it really just tugs at the heartstrings so much, and it really captures that wonder, that feeling you get when you look at the night sky, and that feeling I get of just pure joy when you're doing, your own research of astrophysics and astronomy like this. I just really enjoyed that side of it, and I can see now why so many of my colleagues, and I'm sure so many of you as well, were inspired by this film. So I really enjoyed doing this again. I think I'm definitely going to make Astrophysicist Reacts a series. So if there's any more classic sci-fi, TV or film that you think that I should react to, anyway, not even classic, new sci-fi as well that I probably haven't seen because I'm so busy, chuck it down in the comments, and you never know, that might be the next video in this series, and I'll see you then. Before we get to the bloopers, I just want to thank this week's video sponsor, Brilliant. Brilliant is a website and an app that was founded on the principle that you learn best by doing through active learning and not just necessarily by watching a lecture or a video like this one. After this video, I thought you lot might enjoy their course on waves and light. It goes through what sound waves are, what wave frequencies and velocities are, but also it specifically has a section on light and electromagnetic radiation and how we measure light with telescopes as well. I figured that would help clear up that whole listening to radio signals thing that they had in Contact. So if that sounds like fun to you and you want to support me and my channel, then head to brilliant.org/Dr Becky, that's DRBECKY, and sign up completely for free. Plus, the first 200 people that go to that link, which is linked in the video description below, will get 20% off an annual premium subscription, which is pretty amazing. So thank you so much to Brilliant for sponsoring this video. And now, roll those bloopers.
Arecibo, right?
Wait, Matthew McConaughey's in this? How old is Matthew McConaughey? Seriously. How old is Matthew McConaughey? Probably not gonna get 51? What?
Dr. Arroway. I presume.
Is that Ollivander? Kind of sounds like
him. I've had my eye
him.
on you a long time, Doctor.
Is that him? It is him. I didn't recognize him without all the crazy hair.
Or that your experience is the result of being the unwitting star in the farewell performance of one S.R. Haddon. A man with the means, the motive, and the opportunity to play you, and indeed the rest of us, as pawns in the biggest, the most elaborate, the most expensive hoax of all time.
Oh, I swear to God, if this turns out to be a hoax by Ollivander, I am going to absolutely flip my lid. All right.